Hi everyone, thank you for watching this webinar on Scala.js today. So my name is Luca, I'm the community organizer of London.js. Today we are going to host Otto, that is a great speaker, very famous about Scala. I had the opportunity to watch one of his YouTube video and I was impressed about Scala.js, so I reached him and I asked him to join us just to share how cool could be working with Scala.js. And I think it's good also for everyone to have, let's say, some insight from other programming languages that could help us on our daily job. If you have any question during the presentation, please feel free to mention London_JS on Twitter and ask your question there, or just write the question on the input field that is on the bottom of the playback on this webinar. So thank you very much for watching, and I hope that you will enjoy the webinar. Have a nice day, everyone, and Otto, is up to you now.
Okay, thanks. I suppose I'm live now.
Yeah, you are.
Good. So welcome on my part as well. I'm doing this webinar from my home. As you can see in the background, there's a lot of stuff from my workroom, but I think we'll be switching to the screen sharing in no time, so you don't need to be watching myself much longer. But today, so the topic is on Scala.js, how that applies on front-end development, what are the benefits, why you should give it a try and see whether that works in your particular application, and also what other benefits there might be just by learning to use Scala.js for a while. But yeah, let's do some screen sharing with the slides. All right. So the topic for today is Scala.js especially for large and complex front-end applications. And so my name is Otto. I live in Finland. I've been programming in Scala for about 4 years now, and using Scala.js a little over a year. It's rather new. I think it had a 3-year birthday just the other month, but it's already pretty well production capable, and a lot of big applications are being written in Scala.js even as we speak. So let's start by looking at this kind of simple JavaScript code. That what does it actually do? So basically, we create a AJAX request, call Twitter API, and then once we get the result, we do some JSON parsing and then use jQuery to output those tweets into a location defined by the ID. But is it actually really JavaScript? It looks just like JavaScript, but is it really? So if we take a closer look, we see this one thing here, which is defining a type for the parameter for that function, which sort of doesn't fit the JavaScript word. So it might be actually TypeScript, but actually this is just normal strongly typed Scala. So the benefit of Scala.js is that it's very familiar in syntax for JavaScript developers, unlike, let's say, ClojureScript or PureScript or even Elm, that are sort of quite different from what it comes to the syntax and the usage of the language. So it makes it very easy to transition from JavaScript to Scala.js and back, and to use those interoperability of both languages. So what is Scala.js? It's basically a compiler. You can write normal Scala code and then you compile it to JavaScript and you run it in the browser. Of course, you can also run it in Node if you want to do it on the server side. But usually, because Scala is of course based on JVM, it's Java compatible. So if you are working on server side code, you would be just using regular Scala without the Scala.js step. So it has a full support of the Scala language. It's actually using the Scala compiler. It's just emitting JavaScript at the other end instead of producing bytecode for JVM. So you get all the functionality of the Scala language, even the complex type systems and macros and all the fancy stuff that you have in Scala. But it also has full interoperability with JavaScript. So you can use basically all JavaScript libraries out there. And as the syntax is quite similar, using those libraries is very familiar, that you would be just calling them like in the example before. It just looks just like calling the jQuery API, but you are doing it in a type-safe manner from Scala. And the compiler is very good. It compiles good JavaScript. It's optimized heavily. The code size is pretty good. So you don't usually have to worry about performance or the code size when working with Scala.js. And there's the small enough. And even though some people consider Scala to be sort of slow compiler, in practice you don't really notice this, that you just write your code and it's incremental compilation, typically 1 to 2 seconds per iteration. And because the IDE has much better support for Scala than for languages, dynamically typed languages like JavaScript, you don't need to really compile that often. You quite often spend a lot of time just in the IDE editing, modifying your code, and you see automatically whether it works or not. And then you just try it on the browser by compiling it into JavaScript. So let's take a quick live demo here to see what it actually looks like. So this is Scala Fiddle. It's currently under development, so it's not publicly available at the moment, but it's basically the same idea as JavaScript Fiddle, that you can try writing code in the browser, and it actually gets compiled on the server side, and then you get to see the results. So here we have a very simplistic hello world application that I can just compile. Well, it actually has been compiled already, so there is no change. As you can see, the compiling cycle is just less than a second for something simple like this. But let's try to write something a bit more complicated. The Scala Fiddle also has some helper so that you can easily query, for example, the width and the height of the canvas. So we can now combine them into this tuple and then actually extract them back to these variables h and w, which will be now saying that what are the dimensions of the canvas. And then let's define a time value. Start with 0, and then we can just use the normal DOM functionality, DOM window. Yes, use the set interval, and then we'll define a simple function to do something within there. So let's draw a circle. Circles are always nice. So we use the width and divide it so that we get the radius, and then we actually make the radius go smaller over time. So we just decrease it by the time value. Then let's calculate the angle. We can just take pi and then time divided by 100, and then we get the x coordinate. So all this is pretty familiar. It looks exactly the same as would the same code in JavaScript. We get the angle, and then Let's copy paste that and calculate the other coordinate by using sine. And then again, we have access to the canvas rendering context, so we can just fill a rect at location x, y, make it 3 by 3, and then we want to advance the time by 1, and let's actually make the color red. And then we compile, and we have an error because I'm using weight and not width. So you can also get the errors here in the fiddle itself. You get to see what's going wrong. I forgot to put the time parameter there. Let's try again. All right. So this is a sort of convenient way of trying out different things with Scala.js, even if you don't want to install it on your computer. So this will be part of the Scalalang website and also the Scala.js website in a few weeks. So if we go over what happens here is basically first we extract the height and width of the canvas, then we initialize the time, then we set the fill style, then we basically call the DOM window function to call this callback every 10 milliseconds, and then we just do the basic calculation of the location, that where should we draw and what should we draw there, and then it just goes on and on and on indefinitely. So that was a very simple example. But let's try another example by creating some actual DOM elements instead of doing this canvas rendering. So let's create a select element. Now here I'm using a library called Scalajs, which is like JSX, except that you are just writing normal Scala code, that you don't need to use the sort of XML syntax for defining DOM elements. So we can just have an empty select element, and then we can use the output, which is a div inside that output pane, and then we just add the child element there, and let's see what happens. Okay, now we have this fancy empty selection box right there. So let's put something more interesting in there. I'm just going to copy paste some country values here, so I don't need to type them in. And let's create actual options for that selection box. We are going to take all these countries, which is a list of strings, and then we are going to map over them. We get one country out of there, and we are just going to create an option element with a value of country, and also the contents will be country. And then instead of having an empty select, we are just going to put the cell opt in there. Now, whoa, we have a list of countries to select from. We can also add here a style definition, that if the font is too small, we can just go and switch over to a bit larger font, just like that. And we have big fonts. So this is one of the benefits of Scala.js, is that, as in Scala, you can have these domain-specific languages, so that you can define languages within Scala, and this is basically now defining a language for creating HTML. So we have all the HTML elements there. You can do SVG. You have all the attributes there, and all of these are type safe. So if I make a mistake, let's just write something like sty instead of styled, it's going to be an error. Or if I try to, let's see, if I try to put 2 into style. Okay, that works because it doesn't check those values. But basically, all these things are defined, and you can easily see them when using an IDE. Later, we'll be using an IDE in another live demo, so you can see that how easily you can check what goes in where and what kind of options are available. But okay, so this was just a quick demonstration of what Scala.js looks like and how you can just do it in your browser, just like JavaScript. Of course, in reality, when we are talking about large and complex applications, you're not going to be using Scala Fiddle, but this is a good playground for just trying out different things and seeing how they work. All right, let's go back to the slides. So how does Scala.js compare to all these other different languages that are out there? There is TypeScript, very popular now with Angular 2 coming up. ClojureScript is more like Lisp. CoffeeScript has been big in the past. I don't know how well it's doing nowadays. Google created Google Web Toolkit because they had all these complex web applications and they wanted to have their own tools using Java to create that. And the reason why there are so many options to JavaScript and why so many, there are like 170 different languages that compile to JavaScript. And the reason is that JavaScript is a great platform, but it does have some problems on its own. JavaScript is not very safe, so you want to have something safer, so that sort of prevents you from making mistakes. You want more modularity, you want to be more expressive, you want to be able to reuse your code more, and all these things are sort of affecting why people are switching to some other languages. In some cases, you are able to actually use one language across client and server. Of course, with JavaScript, you can use it also on the server side with Node.js, and that's actually also true with Scala. And especially with large and complex applications, you want the language and the environment and the frameworks to support better tooling and to have better IDE support, so you can navigate your code easier. You can make changes, refactorings with ease without worrying that will something break if I change this here and there. And just the other day, Andre Staltz posted this blog posting that all JS libraries should be authored in TypeScript, even when they are being used in JavaScript. So there are reasons like documentation and making the types sort of specific, even in code where you don't really use the types. So it makes sense to use these, let's say, more advanced languages on top of JavaScript. So why now? What has happened? If we take a look at the front-end evolution, we start at the, let's say, Stone Age, where jQuery was the king of the hill, and everybody was using that to write sort of small JavaScript animations and maybe some form validation and stuff like that. And everything else basically came from server-side rendered HTML paged, and you were maybe doing a few AJAX calls to the server, but otherwise it was very mutable. You were just doing direct DOM manipulations, changing the HTML on the live page, and sort of keeping the JavaScript side was quite simple. Then we entered, let's say, medieval times, and now we have this single page app where the HTML template is driving everything. So you have JavaScript that uses templates to create the UI, and you have REST APIs. So this is the time when Backbone, Ember, Angular were very popular, and of course they are still very popular. A lot of sites are still being implemented using these technologies, and these technologies are very good for what they were meant for. But now we are getting more and more complex applications that are more and more sort of JavaScript centric, so that the logic from the server side is moving over to the client side, and even the DOM is being generated by code in frameworks like React. You're using these advanced methods of communication like GraphQL, Falcor, and also the JavaScript itself is sort of moving ahead faster than the browsers. So you need to use these transpilers to transpile ES6 or ES7 features onto the ES5 platforms that are out there. But then the next generation is coming up in the modern times. So now we are seeing a sort of rise of new languages. We see Scala, Clojure, Elm, TypeScript being used on the front end. And the reason is that the complexity is growing on the front end side. So you have all these complex client-server systems where you need to have shared code. And also the JavaScript is sort of reduced to a compile target. It's like the assembly language on the web, that you don't really care what the JavaScript looks like after Babel translation. You're not interested in that. You are just using some higher level language and it will be producing JavaScript, and that's it. And the mobile as a platform is becoming more and more important. So what are these large and complex front-end apps I've been talking about? So we would define them by having a large code base, that you have like 10,000 lines of code or more, sometimes 20, 30,000. So this is not about small applications. In small applications, you don't face the troubles and the challenges that you do in large applications. And in these kind of applications, all the UI functionality is defined in JavaScript. So it's a single page app using a JavaScript framework like React, Angular 2, Ember, or any of the other frameworks. So this is not like something that the server is rendering anymore. The server is just basically giving you JSON data, and everything else happens on the client side. So that means that a lot of the logic that used to be on the server side is now on the client side, and that makes the client side more and more complicated. And it's not just that the server is giving you JSON, but the way the server is talking to the client is also changing. You get all these sort of reactive streams and Falcors and GraphQL, so that you describe to the server what you want, and then the server gives you the data. It's all very asynchronous. You have to cache the data on the client side, and all the UI operations end up being async. So you just send a request for data, and when it comes back, then you actually do rendering. So the state management on the client side, it gets also more complicated, which is why these kind of libraries like Flux and Redux are getting much more popular, because they make it a lot easier to manage that state. And also offline support is getting more and more important, especially for applications where you have mobile users. They don't always have access to the network, so you want your application to be usable. So you need to share the business logic, not just for performance reasons, but also for the offline functionality, so that you can do things even when you're not directly online. And when you have a large development team, that also brings new challenges, that you have a lot of people writing code. Can you read the other people's code? Can you access it very easily? Can you understand what's it doing? And so on. So these are all sort of familiar problems for a lot of developers who have been doing backend coding for dozens of years. But on the front end, this is kind of like a new problem. So a lot of these new frameworks have been built especially to solve these problems of large and complex applications. So they give you the framework that you can work in it with a large team, so that people are focusing on their own things, and the framework is sort of well, not exactly hiding, but making it easier to integrate other people's work into your own work. So the challenges are, when you have a large team and let's say you have people entering the team, how do they adopt this code base? If you have 20,000 lines of JavaScript, it's going to be very difficult for people to get productive with that, because it's all sort of inaccessible. In other languages like Scala, you have great IDE support. You can navigate the code much easier. You can access access the help online within the IDE. You can see what the code is doing and what it's calling and where it came from and where it's going. All the parameter types and all the stuff is available to you, unlike in dynamically typed languages like JavaScript or Clojure. It's much more difficult for the IDE to provide this kind of support. Refactoring is a daily chore in most applications. You have to make some changes. When you make changes in say JavaScript, it's quite difficult to be sure that nothing is going to break. So you end up doing a lot of tests that are just basically running the code to see that nothing actually breaks. But when you have better type safety, then a lot of refactoring becomes much easier. And then the client-server communication. This is especially problematic because you usually have different teams working on the client side and the server side. So basically, you are just transferring JSON back and forth. But how can you know what's in that JSON? How can you make sure that the data models actually stay in sync between these two? Not to mention that you might have other clients than the web client. You might have iOS, Android clients as well talking to the same server and using the same data models. So you have to be very, very careful in that. And to manage these kind of large front-end apps, there are a couple of approaches that have been becoming more and more popular in the JavaScript developer communities. So typing is one. You have TypeScript and Flow, which basically provide typing on top of JavaScript, so that you can be sure that when you are calling functions, you are delivering correct parameters, and the return values are what they are supposed to be. And this is basically helping you to find errors before you actually run the code. So when you compile it with TypeScript compiler, it will basically complain about all the typing errors. And even though typing has been sort of traditionally a bad thing in JavaScript, that people really like the dynamic typing because you can just do whatever you want and everything just works until it doesn't. But in reality, there's always the typing. It's just that it's sort of hidden, that you cannot assume that any function can get any number of parameters in any order and so on. But you always really have the types in there. But these are now making it more explicit. In Scala.js, because Scala is very strongly typed language, all of this is of course built in. You don't need to do anything else. It has very strong type inference, which means that usually you don't need to explicitly write out the types except in function parameters and, let's say, class method and member definitions. So the second thing, functionality. Functional programming is becoming bigger and bigger. A lot of these frameworks are, if not real functional programming, but they are using a lot of things that are coming from the functional programming world. So if you're using React or Flux on top of it, Redux, Scala.js, all of these are about having, let's say, these pure functions that get something as an input and produce something as an output. Very little side effects, very sort of easy way to see what's going on. Usually the data updates are unidirectional, so that you only make changes in one direction. So you don't have this kind of two-way data binding as you have in, let's say, Angular, but you just send actions to Flux controllers and then they make some changes, or in Redux the same thing. Again, Scala.js being built on Scala has full support of functional programming. The standard libraries in Scala are very functional programming friendly, and there are a lot of libraries out there that really take you all the way to real functional programming if you want to do it Haskell style or Lisp style and so on. And the third thing that's sort of quite new is the immutability. For example, Facebook published this immutable.js library just, I guess, last year, because there are some benefits, especially when you have functional code. Then having the data as immutable makes makes many things a lot easier. So this is again something quite new to the JavaScript land, but again in Scala it's been there from the beginning, and all the collections are available as immutable and mutable. And actually the collections within immutable.js, the way they work, the logic has been basically copied over from Scala and Closure collections. So they have been as an example for immutable.js. And then the tooling. There used to be a time when you could just write JavaScript in an editor and you would just load it into the browser directly and everything would work just nicely. But now you have a lot of different tools. Every year you get a bunch of new tools for managing that code base, and you have to build using these tools, and it gets closer and closer to, let's say, traditional application development. Whether you are using C++ or Java, you always have this tooling there to make things happen. And especially in larger applications, this is definitely needed. You just cannot really do big applications without proper tooling. On the Scala side, we have this SBT, Scala build tool, which takes care of the building of applications. It has a lot of plugins. It's the sort of de facto tooling for Scala applications, and also the Scala.js is actually a plugin for SBT. So that's how it works and does its own compilations. And SBT is actually built in Scala, so the SBT build files are Scala programs. So you can do a lot of things within the SBT build tool. But all these things are sort of needed for building these large front-end applications, that you can't just take jQuery and run with that and expect to be able to come up with a nice big application. Okay, let's move on to another live demo. This is no more like, let's see, it's in there. So this is a tutorial I made for basically to learn Scala.js myself. So this is a single page application tutorial using React, and this is like a more realistic case of how Scala.js works. So let's take a look at some interesting things here. So this is where the application starts. We define a JS export so that we know that this function will be called outside of our application. So we just do some logging first. We define actually styles also using Scala code. So we add those styles, and then we initialize a router for our React application, which is defined above, and then we just render the router, and that's where the application then starts. And here we can basically navigate. Okay, let's see where is this router defined. Okay, it's there. Where's the config? So we can very easily navigate the code using IDE. We can see what's going on here. We can navigate to other, let's say the dashboard application or dashboard component is defined here, and so on. So the interesting thing, for example, in the rendering, is that we are using a similar approach as the Scala tags before. So we have these div and h2 elements here that we are building the component DOM just like in React using JSX, but instead we are now using these functions provided by the Scala.js React library. And we have these sort of funny looking names here. These are not operators, these are actually names. And the reason for this is basically that these HTML tags are usually quite short named, that you have all these div, A, I, P, and so on. So they tend to create some conflicts with your own code. So having this kind of namespace for the tags and another namespace for the attributes makes it a lot easier to make sure that you don't make any mistakes there. But this is basically just defining a div with some components in there, and then building that component so that it's then a normal React component. So this is basically a facade or interface to React. So there is no, let's say, real code. This is not replacing React, but this is just wrapping React in a Scala library so that it's easier to use from Scala code. Let's see, chart definition. And then if we want to use existing JavaScript libraries, then we can define these facades. So we define them by annotating using this kind of js.native annotation, and then this is something that exists in the JavaScript library, which is chart.js in this case. So this is now describing a chart data set, that what does it actually look like, so that how can we use it from Scala. So we have like label, fill color, stroke color, and the data is an array of doubles. And these are just like descriptions for the compiler so that it knows that, okay, there is a native JavaScript library which is using this kind of data. So whenever I'm accessing it, I'm using it through these functions. And this is basically the entry point for a chart, that I can create a new line chart using that data that's being defined over there. And these facades, they don't need to be like 100% ready. It's like in TypeScript you have the type definition files, and these are sort of similar. You can just define enough typings that what you want, and then you just go with that. And otherwise it's really simple and straightforward to use. And there's a lot of existing facades for all the popular libraries, so you don't need to do it yourself. But if you do need to do it, it just takes a few hours for a typical library to come up with a good facade for that. But let's look at the sort of more complicated things, that how do we actually get some data around. So this is let's see, where should we go? Let's take a look at so this is a client-server application, and we have a server which is defined here. So we have an API between the client and server, and this is just an interface. We have these couple of functions, like getting a welcome message, getting to-dos, updating and deleting the to-dos. And if we want to see where this to-do is actually used, okay, now we went a bit too far. So on the server side, we have this API service, which is now basically implementing the API that we defined. So we have the welcome message here. We get a string input, we return a string, and this is just producing some string that we can then show in the UI. And the pretty thing is that when we call this from the client side, which is the message of the day. So this is basically the component that shows the message of the day. So we are using a Redux style model here, so that we are just dispatching an action that, okay, we want to update the message of the day, and then this will be taken to the handler, which is the circuit. And here we have here. So this is the handler for the update message of the day action. So we are calling the welcome function with the user information, and this is now using a library called AutoWire, which allows us to use the same API. So it will expose the same API on the client side, and we can just make a call like this. We don't need to do like an Ajax call ourselves, and this is all type safe. So if I try to add more parameters here, it's not going to work because it knows that this is the welcome function defined here in the API, and this is automatically converting this call into a post message. It wraps the parameters into JSON, and then on the server side it extracts the same and then calls the actual function on the server side. And the good thing about this is that when we make some changes here, we can refactor easily. That we can say that, okay, this is now welcome message. As we can see, it automatically changed wherever it was used. Let's see on the server side what happened over there. As you can see, also on the server side, we made the change. So if something in the refactoring goes wrong, then the compiler will complain that, okay, you are doing things wrong, that you should really fix things before running. You don't need to do a lot of testing to make sure that your code still works. The IDE and the compiler is basically doing all that work for you. Okay. But let's get back to the slides. So the point in the live demo was basically to show that you can do quite complicated things in the front-end application. You can do refactoring. You can navigate the code very easily. It's quite easy to understand. Actually, let's look at a couple of the. So you get access to these definitions, and if there is like help functionality documentation given to that function, you can easily see what it is. For example, here is all these tags, HTML tags have the definition copied from Mozilla Developer Network, so you can see what these paragraphs are and so on. And so you don't need to go to the website and see that, okay, what parameters are supposed to be here, what should I use with this function and so on. It's all here in the IDE, because the IDE knows everything, knows all the types, knows where everything is coming from. So it makes that part of development much easier. And also when you are seeing new code and you don't really know what's going on, it's much easier to get going with that. So what do JavaScript developers get from let's say, using Scala.js? First of all, you get everything you have in ES6 or ES7. You have the arrow function, fat arrow function. You get the destructuring. You get the string and interpolation. Basically, all the features that you get in these new JavaScript standards. But you also get everything you have in TypeScript. You get the types. You get the typing. You get generics. You get all that stuff. Just by using Scala. And also you get everything you have in immutable.js, because the Scala collections are basically what immutable.js is based on. But you also get, in addition, a very great language, at least in my opinion. The standard library is very extensive. You rarely need to go beyond that. You get access to real functional programming, but you still can access all the JavaScript libraries. But you also get this peace of mind that you don't need to worry about that. Is my code going to blow up in production because I forgot something somewhere? The compiler and the typing really makes it much more safer. And then why would you want to try Scala.js? Well, these were just published very recently, the Stack Overflow Developer Survey 2016. So Scala is one of the most loved languages out there. For some reason, JavaScript didn't really make it on this list. But so people who are using Scala really like it. And also, if you are a proficient Scala programmer, you can expect to get paid very well. It's in the top tier when it comes to the salary ranking. So Scala.js is especially good for JavaScript developers because the syntax is very similar. It's very easy to start using Scala.js. You don't need to learn a totally new language. You can basically almost copy paste your JavaScript code into Scala and just make maybe a few modifications, get rid of all the semicolons, and then it's pretty much valid Scala code, and you don't need to suffer from the now famous JavaScript fatigue with all the different things. Everything is always changing in JavaScript. In Scala, it's much more stable. You get the superb IDE support. You can do a lot of things in IDE where in JavaScript you would have to go and try it on the browser and see whether it works. In IDE, you can just do it right there. But also, even if you never actually end up using Scala.js, just learning Scala will make you a better JavaScript programmer, because there are a lot of idioms and ways of doing things in Scala that are applicable to other languages as well. And especially if you don't have a lot of experience in other languages besides JavaScript, then learning a bit of Scala might be really, really good. And Swift, if you are interested in iOS programming, Swift is a language from Apple that replaced Objective-C, and it's very, very similar to Scala. So if you know Scala, then Swift as a language is very, very much the same. You can start writing Swift right away just by basically learning the libraries of iOS. But the language itself is so close to Scala, it's hard to imagine that they didn't actually take a very close look at Scala and basically copied a lot of those features. There's a broad and active ecosystem for Scala.js, a lot of libraries out there. More and more Scala libraries are being adapted to work with Scala.js, and a lot more JavaScript libraries, facades are being built for them all around. And basically Scala.js has been production ready for over a year now, so people are using it for real stuff. Here are a couple of examples of large Scala.js applications out there. Quirky, which is an open source online information tool, you can actually access it. It's in beta right now, but you can see the source code in GitHub. It's pretty big. There is a metabolic analyzer for doctors, 14K lines of code, also in live use by medical people. There is a Seventh Sense application. There's a network management GUI, really big. It used to be written in Adobe Flex, and now it's being rewritten in Scala.js. And there are other applications like this one, finance tech application, which is also really big. And these are like serious applications. They might not be, let's say, B2C applications in that sense. They are more like B2B, but they are solving real problems in real businesses as we speak. And how to get started? Just head out to scala-js.org and see the documentation. And as I said, the Scala fiddle will be there available in a few weeks once we get some of things fine-tuned and a little more testing. But also it's good to join the Gitter room. There are almost 800 people on the Scala.js Gitter room. So if you are interested in talking to those people who have been using Scala.js to get their experiences, that's a very good place to start. Really great community, a lot of helpful people who are helping newcomers and experienced people like us as well. So just head over there and start asking questions. But I guess that's it. So now is the time for any questions if you have.
Yeah, thank you very much, Otto. I just checked Twitter and also the chat under the playback, but I didn't see any question for now. So I think we are good. If you want to, can you share again the first slide where you have your Twitter account? So
Yeah,
people, if they need to contact you, they will be able to do that directly from there. Exactly, great. And so first of all, I would like to thank you. It was really, really a great introduction to Scala.js. I really appreciate it. Yeah, I think that that you highlight a lot of strengths of these of Scala.js. So I'm really glad that you did this presentation. So thank you very much.
Thank you.
There is a question. There is a question. Let me refresh here. Can you do a comparison with Node.js?
Okay, so Node.js is so you can use Scala.js on Node.js. That people have been using Scala on Node. So one of the applications for that is that if you are using, let's say, Amazon Lambda, which is like a running a single function in the cloud, then sometimes it makes sense to write it in Scala, but to compile it to JavaScript and use Node.js to run it, because Node.js starts much quicker than the Scala JVM. It takes less resources and so on. So there are cases where you would want to use Scala.js on Node.js. But otherwise, I think the comparison between Node.js and Scala is the more relevant thing, that you would be using Scala and some of the Scala backend libraries in comparison to Node.js. So Scala.js has been primarily designed for the front end applications.
Cool. I hope that you answered the question of Dean. Apart from that, so thank you again for your talk. I would like to remind to everyone that the next meetup, live meetup of our group will be the 7th of April regarding Chrome Devs Tools. So if you didn't sign in to the meetup, please feel free to do that on meetup.com. Thank you very much to attend this webinar. Thank you, Otto, for sharing with us a lot of great information, and have a nice weekend, guys.
Okay, thanks. Bye-bye.